Hi everybody. In this video, we're going to go over the review sheet for test number 3. In the first question, we're going to be constructing an equilateral triangle. So what we're going to do is we're going to make a triangle whose sides are all the same length as the line segment that's given. In order to do that, I'm going to first copy the given line segment. I'm going to put my compass point at one endpoint of the line segment. I'm going to open up the whole way to get the length of the line segment, and I just put a little arc to show that I measured the length so that people know that I used a compass. Then, using the same distance that we just measured, I'm going to make an arc. Let me just get my compass to work. There we go. And then I'm going to take my compass and go over to the other endpoint of the line segment. And using the same distance once again, I'm going to make the same arc. Through that point where they intersect is where I'm going to draw the sides of my triangle. From the endpoint of this side to the intersection point. From the endpoint of this side, or vertex, to the intersection point. And it says to explain in words how I know that I made an equilateral triangle. So I'll write that down over here. This triangle is equilateral because all the sides are the same length or are congruent. There we go. We measured the original line segment with the compass and copied it to make the other sides. So we do know here that all three sides are equal to each other. Okay, moving on to the next one. AS is a diagonal of trapezoid star. I don't really know what that all means, so let me move on. I see my figure here. I see my trapezoid, whatever that is. RA is parallel to ST. That stuff I'm familiar with. Angle ATS is 48 degrees. Angle RSA is 47 degrees. And angle ARS is 68 degrees. We need to find the longest side of triangle SAT. So triangle SAT is this triangle over here. So right now, I don't have any measurements inside this triangle except for the 48-degree angle. So I have to try to get some more measurements to figure out what the longest side of this triangle is. So in this other triangle, RAS, I already have two angles. And we know that in a triangle, all three angles add up to 180 degrees. So if I already know what two angles are, let me add them up. So I have 68 plus 47, that's 115. And let me subtract them from 180. 180 minus 115 is 65. And that's that angle right here. Now that I have this angle, the 65-degree angle, let me think about how I'm going to get more angles inside the yellow triangle, which is what I'm interested in. Our given information is always there for a reason, and as soon as I see the words parallel, the information parallel, I start thinking about parallel lines cut by a transversal, my angle relationships. Let me get my highlighter. I'm going to highlight the two parallel lines. and the transversal that intersects them. And notice this angle and this angle are in the corner of the Z shape, and that means they are alternate interior angles. If you take a look at these two angles here, they're both inside the parallel lines. They're on different sides of the transversal. So we have alternate interior angles. And if you highlight the parallel lines and the transversal and you see a Z or a backward Z, in the corners of the Z are your alternate interior angles, which are congruent when we have parallel lines. So that's an easy way to identify alternate interior angles. Now that I have two angles of the triangle, I can find the last one. I know once again that all angles of a triangle add to 180. So 65 plus 48 is 113. If I subtract 113 from 180, I get 67. So I see that none of the angles are the same measurement, which tells me none of the sides are the same measurement. This is a scalene triangle. I'm interested in the longest side. The longest side will be across from the biggest angle, which is the 67-degree angle. So the side across from that angle is side ST. Write an equation of the line that passes through the point 6, -5, and is parallel to this line. So first, if I have a parallel line, that means the slopes are going to be the same. The slope of the original line and the slope of the parallel line will be the same. So first, I need the slope of the original line. I have the equation, but I can't see what the slope is. And that's because it's not in y equals mx plus b form. So I'm going to start off by taking the equation of the original line and putting it into y equals mx plus b form. I'm going to subtract 2x from both sides. And last, I'm going to divide everything by -3. Negative over negative becomes a positive. Okay, so now I can identify my slope. And I see the slope is 2/3. So the slope of the line parallel to this one is also going to be 2/3. I have my slope. I have the point that it needs to pass through. I can use point slope form to easily write the equation of the line. Point slope form is y minus y1 equals to m x minus x1. x1 and y1 are the x and y coordinates of the point that we're using. So we have y minus, our y coordinate is -5. Our slope that we're using is 2/3. Parallel lines have same slopes. And the x coordinate of the point that we're using is 6. This is enough. You can leave your answer just like this. Perfectly valid equation of the line. If you wanted to take it a step further and solve for y, or if it was a multiple choice question and your answers were solved for y and you had to, you could take it a step further. We could distribute the 2/3 x, 12/3, that's 4. But I would highly recommend leaving like this. It is so easy to make a mistake when you're solving for y. So if it's a short answer question and the question does not tell you it has to be solved for y, this is an equivalent equation of the line. And all you to do is plug in your point and your slope. Okay, let me get my compass. So we're going to construct the altitude of this triangle. And fun, it is an obtuse triangle. So it doesn't specify what side we have to make the altitude of. So I'm going to make the altitude of side BC because I know that could get a little tricky. So what I'm going to do is, since I'm making the altitude to BC, an altitude is a perpendicular line that passes through the opposite vertex. So I know that if it's an altitude to BC, the opposite vertex from BC is A. So A is where I want to put my compass point on to make my perpendicular line. That's the point that it needs to pass through. Then I'm going to make an arc. It doesn't matter the distance. Oops, I think it needs to be a little bigger than that. The only thing that matters is that when you make your arc, you hit the side of the triangle that you're making your altitude to in 2 spots. So I want to hit BC in 2 spots. I want to make sure I definitely hit it, so I'm just making it really big. So I hit it in 1 spot here, but here's off the triangle. What I can do is I can, oops, sorry, on the computer it's a bit messy. It's hard to make this accurate on the computer. I can use my straight edge and I can extend the side of my triangle. And I'll just extend my arc a little bit more because I didn't extend it enough at the beginning. There we go. Once again, I'm not going to be 100% accurate on the computer, but I try as best as possible. It's a lot easier to do this by hand. There we go. Now, what I'm going to do is I'm going to take my compass. Oops. And I'm going to put it on one of the intersection points. And all I'm going to do is make an arc. I'm going to go over to that other intersection point. And using the same distance that I just used, I'm going to make another arc. If I don't keep moving everything else around on the screen at the same time. And right where those arcs intersect, through the opposite vertex, is where I'm going to draw my altitude. So it's really just 3 arcs. First arc with the compass on the point that you wanted to pass through, which would be the opposite vertex from the side that you're doing the altitude to, and make an arc that hits the side of the triangle in 2 spots. And as I did here, you might have to extend the side of your triangle to see where that intersects. Then, compass on this point, arc. Compass on this point, same arc. Doesn't matter the distance. And here, I have the altitude. Oops. I have the altitude to side BC. It forms a right angle. It's a perpendicular line through the opposite vertex. So I just graphed the triangle and I need to find where the medians intersect. Remember, a median connects midpoint of a side to the opposite vertex. So I need to find the midpoints, and once I have the midpoint, I can connect to the opposite vertex. So here I have my work to find the midpoint, so you can check with your own work. And I have plotted the midpoints of each of the sides of the triangle. Since a median connects midpoint to opposite vertex, I'm just going to use my straight edge and connect each midpoint to the vertex point of the triangle that is opposite from it. And I can clearly see where the medians intersect. Oops. Right here at this point, that is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. That is the point 7, 5. That would be the centroid here. Okay. Next one. We are told that GH is congruent to IH. Before I fill in anything else, I'm going to stop right here for a second because we have a triangle that has two equal sides. And we already talked about in class that if our triangle has two equal sides, the angles across from the congruent side should be congruent. So the angle across from this congruent side is this angle, and the angle across from this congruent side is this angle. So I already know I have two congruent angles inside this triangle here. We're told that angle EGB is 50 degrees, and angle DIG, this exterior angle, is 115. And we need to figure out why AB is parallel to CD. So remember, we have a couple ways of showing lines are parallel. We can show that we have congruent alternate interior angles, or we can show that we have congruent corresponding angles, or we can show that we have supplementary same side interior angles. Any of those ways would work to show that we have parallel lines. So let's see what we can do here. I already know that these two angles are supplementary. So to find the one inside the triangle, the interior angle, I'm going to do 180 minus the exterior angle, and I got 65 degrees. And that tells me this angle is also 65 degrees. I also see that this angle and this angle are vertical angles. They're formed by intersecting lines. They come out of the same point, and they are non-adjacent. And the last thing that I see I could fill out right away is now inside this triangle, I have two angles, 65 and 65. And I know all three angles of a triangle make 180. 65 and 65 is 130. So this one needs to be 50 degrees to make the 180. Let me pause and look for some angle relationships that I could use to prove the lines parallel. I see a lot. If these are the lines that I want to prove parallel, and here's my transversal, notice my same side interior angles. One is 50 and one is 65. That does not add up to 180, so we're not going to be able to use that. So instead, when I highlight my parallel lines in my transversal, I see my letter Z. And in my letter Z, in the corners, I have my alternate interior angles inside the lines on different sides of the transversal. They are congruent, they're both 50, so that does show the lines forming them are parallel. Another option, aside from the alternate interior angles, is we have corresponding angles here. Where the parallel line meets the transversal, we have top right, top right. Since we have congruent corresponding angles, that also proves the lines are parallel. So let me write down my explanation. Since angle EGB and angle GHD are congruent corresponding angles, lines AB and CD are parallel. I know angle EGB and angle GHD are both 50 degrees. And we showed our work here in the diagram. Point P is the centroid. That means these segments here are medians. And we know that the centroid splits each median in a 2-to-1 ratio. PM is the shorter part of the median. And that's 2x plus 5. BP is the longer part of the median. And that's 7x plus 4. We need to find the length of PM of the shorter part. So we need to find the x value and plug in for PM. Since I know that there's a 2-to-1 ratio, I know that the longer part is double the shorter part. So I can take the shorter part and double it to get the longer part. That's 4x plus 10. Quickly solving my equation. Subtract 4x on both sides and subtract 4. And then finally dividing by 3 on both sides. We have x is equal to 2. So now if we plug in for PM, we have 2 times 2 plus 5. The length of PM is 9. Here we have an isosceles triangle ABC. Isosceles means 2 congruent sides. And they're telling us that the congruent sides are AB and CB. And we're told that the segments that we see here inside the triangle are angle bisectors. I know that angle bisectors cut an angle in half into 2 equal parts. So this angle bisector is cutting this angle in half. This angle bisector is cutting this angle in half. And this angle bisector is cutting this angle in half. We know that angle BAC, so that's this whole angle here, is 50 degrees. We need to find AXC, so we're looking for this piece right here. If this whole angle is 50, each piece is 25. We also know that if we have an isosceles triangle, triangles that have 2 equal sides have 2 equal angles. The congruent angles are across from the congruent sides. So here I have a congruent side, so the angle across from it is congruent to the angle across from this congruent side. So angle A and angle C are congruent to each other, making this one also 50 degrees, telling us that it's also being split into 25 and 25. Now, oops, sorry, my computer keeps jumping. Now, if we take a look at the small triangle at the bottom, I see that we have two angles, 25 and 25, and we need that last angle. I know all the three angles of any triangle add up to 180. 25 and 25 is 50. 180 minus 50 is 130. So the measure of angle AXC is 130 degrees. We need the equation of the perpendicular bisector. Let me graph it. So we need the perpendicular bisector of this line segment. So we want it to cut this line segment in half and make right angles with it. So the perpendicular part, we know that perpendicular lines have opposite reciprocal slopes. And for the bisector part, we know that since a bisector cuts a line segment in half, it passes through the midpoint. So the two things we're going to need to write the equation of the perpendicular bisector are the opposite reciprocal slope and the midpoint. So first I'm going to find the slope of this line segment here. So let me subtract the y values, y2 minus y1 over x2 minus x1. And we need the opposite reciprocal slope since this is a perpendicular bisector. So that would be positive 4 over 3. The last thing that we need is the midpoint of the line segment. So let's use midpoint formula. Average of the x coordinates, average of the y coordinates. Okay. Now we just need the equation of the perpendicular bisector. So now that we have the point that it needs to pass through the midpoint, because remember, a bisector needs to pass through the middle to split it into two equal parts. So now that we have the point that we're using and we have the slope that we're using, we can write the equation of the line using point slope form, which is really useful when you have a point and a slope. Plug in point slope form. Let me write down what it is. There we go. And then we'll plug in. The y coordinate of the point that we're using is -2. Our slope is 4 over 3. And the x coordinate of the point that we're using is 3. And you can leave your answer just like this. If you prefer to do it using y equals mx plus b form, solving for your slope for your y-intercept and plugging back in, I will solve out for y so that you can check your work if you did it that way. But I highly recommend doing it like this and just leaving your answer in this format. Okay. Construct the centroid of the obtuse triangle below and label the centroid. So the centroid's where the medians meet. So for medians, I need to connect midpoint to opposite vertex. To find the midpoints, I need to make a perpendicular bisector. I'll do this base of the triangle first. Go on to one endpoint, more than halfway down for the perpendicular bisector, arc above, arc below, going over to the other, endpoint of that line segment, same arc. Through those intersection points, I'm going to make my perpendicular bisector. Next perpendicular bisector, and you only need to do for 2 sides of the triangle to see the intersection point. 3 makes it more accurate, but you really only have to do for 2 sides to see where they intersect. Okay? I'll also do the slanted side of the triangle. So I'm going to go over to one endpoint, more than halfway down, arc above, arc below. Oops. Don't want to move around my arcs. That's why the computer is so annoying. Okay, I'm going to go over to the other endpoint. And using the same distance, same arc. Through those intersection points, I'm going to use my straight edge to draw my perpendicular bisector. The point of doing my perpendicular bisectors was to get midpoints. So let me dot where those midpoints are so you can see them. Where these 2 blue lines meet, that wouldn't be the centroid, that's the circumcenter, because these are perpendicular bisectors, and the point where the perpendicular bisectors meet is the centroid, is the circumcenter. Remember, for the circumcenter, the location is outside the triangle for obtuse triangles. But for the centroid, they always meet in the triangle. So this would not be the centroid. Now that I have the midpoints, which is why I did my perpendicular bisectors, all I'm going to do is take my straight edge. Oops. I just wanted to get a different color on my straight edge. So I'm just going to take my straight edge and connect midpoint to opposite vertex, midpoint to opposite vertex. Now I have my medians because medians connect midpoint to opposite vertex. And where they meet, right over there, that is the centroid. And we used perpendicular bisectors to make the centroid. Oh, I shouldn't write that down. That's confusing. Medians make the centroid. We needed the perpendicular bisectors to get the midpoints, but we really needed medians. We connected the midpoint to the opposite vertex. Where the perpendicular bisectors meet is the circumcenter, not the centroid. So we made medians. We used the perpendicular bisector construction to make medians.